1 minute. Yeah, Duhaa, have we completed quadrilaterals also with you?
No, mom.
Quadrilaterals has not been done. Okay, fine. So in today's lesson, class, we shall be completing quadrilaterals. Okay. Just give me 1 minute. Okay. Yeah, Duhaa, you see my screen?
Yes, mom.
All right. So in this lesson, quadrilaterals, what do we have? First of all, Duhaa, you need to understand that what is a quadrilateral. See, before even moving ahead to quadrilateral, the term quadrilateral, I'll teach you what is the meaning of some basic terms. So first of all, you need to know what is a polygon. So if I have a simple closed figure, okay, that's called a polygon. For example, a triangle. So a triangle is a polygon, a square is a polygon, a rectangle is a polygon, a circle is a polygon. So the simple closed curve that is made up of only line, I'm sorry, circle is not a polygon. Mistakenly I said a simple closed curve that is made up of only and only line segments. You're going to have line segments. Like in triangle, you have line segments. In a square, you have line segments. In a rectangle, you have line segments. So a polygon is a simple closed figure that is going to have a line segments, right? That's a polygon. So now we have two kinds of polygons. So a polygon will be a simple closed curve. Now what happens? There are two kinds of polygons. You have convex polygons and you have concave polygons. Okay, two kinds of polygons. You have convex and concave polygons. Now what is a convex polygon and what is a concave polygon? If you look at these figures carefully, um, look at the figures on the left hand side. They are convex polygons. Now why are they convex? Because whenever you are joining the vertex of these figures, see, whenever you are joining the vertex of these figures, what do you get? You get an internal line. Okay, you get a line that's internal to the figure. Like, see, you join these two, the diagonal is internal. Then you join these two, it's again internal. When you again join these two, it's internal. So it's convex. Okay, again, when you join this point and this point, it's internal, so it's a polygon. Convex one. This is also internal, so it's also convex. This point and this point when you join, it's convex. This point and this point when you join, it's convex. This point and this point. So that means any point when you join, it will lie internal to the figure only. Okay. So those polygons will be called as convex polygon. Now, what is a concave polygon? In a concave polygon, the lines may or may not be internal to the figure. For example, when you join this point and this point, you get an internal line, right? But when you join this point and this point, you get an external line, right? So this is concave polygon. Now, when you're joining this point and this point, you're getting internal line, internal line, internal line, but we are having one external line also. So if you will have any of the diagonal that is external to the figure, that's called a concave polygon, right? You understand the difference between convex and concave?
Yes, ma'am.
Yeah. Okay, now what are polygons and what are not polygons? This can also be asked to you. Is, for example, you have this is your figure. So all of these are closed curves, like simple closed curves. So these are all polygons. If you look at these figures, first of all, this one is not closed, so it is not a polygon. If I was forming this line also, now it can be called as a polygon, but it's not a polygon. Why? Because it is not closed. See, this is not closed, so that is why this is not a polygon. Okay. Now, what about the first and the second one? The first one, two lines are lying externally and they are also not joining each other. Like here it is open, so that is why it's not a polygon. Here it is crossing one another. I said that simple closed curve. So simple closed curve, what is the definition of a simple closed curve? That the lines should not intersect one another. Right? That is a simple closed curve. But here the lines are intersecting. So this is not a simple closed curve at the first place. And if it's not a simple closed curve, that means how come is it a polygon? It's not a polygon also. Right?
Ma'am, can you explain the third figure in curves that are not polygons?
This
Yeah,
one?
you said that if we close it, it'll still not be.
No. If you close it, then it will be a polygon. If you close this, now it's a polygon. But when you're not closing it, now it's not a polygon. Okay? Good.
Okay,
Now,
ma'am.
next is regular and irregular polygons. Now, what are regular and irregular polygons? What happens whenever all the sides and all the angles of a polygon is equal to one another? That's called a regular polygon. Okay, like a square, an equilateral triangle, a hexagon. So all of these have all angles equal and all sides equal. So they are all regular. But if you talk about irregular, so they will not have all sides and all angles equal. Like a rectangle. A rectangle will be irregular. Why? Because all sides are not equal. Opposite sides are equal to one another, but all of them are not equal. So that's irregular. Then a scalene triangle, an equilateral triangle, the what we call isosceles triangle. They are all irregular, right? So these examples you can see. For regular, you have first of all an equilateral triangle, a square, then this is a hexagon, this is a pentagon, this is a hexagon. Now polygons that are not regular, this is an isosceles triangle, this is a rectangle, this is another figure, and this is another. Right? These are not regular. Why? Because their angles and all sides and all angles are not equal. You understand this? Now you have this
Yes.
figure. Before the first one, you do one thing. First of all, in small one-line statements only, write down the definition of polygon. What is a polygon? Then write down what are convex and concave. Okay, you can like put on a heading. What is a polygon? Write polygon and then write the definition. So this will be the definition. Okay, then you can write down curves that are not polygons. You can draw these examples. Then convex and concave, you draw one example. Okay, just make short notes so that whenever you are revising, it's easier for you. Quickly do this much. Yes, done. Shall I move ahead?
Yes, ma'am.
Okay. Now regular and irregular also you can write regular and then make one column for irregular. For regular you write same angles and same sides. Irregular you write may or some angles and sides might not be equal. Yeah, done, Duhaa?
Yeah, ma'am. I just have one thing to say. Done, ma'am.
Next you have is given here are some figures and you have to now classify them on the basis of the following. Like which of them are simple curve, which of them are simple closed curves, which are polygons, which are convex and concave polygons. Okay. So now what is a simple curve? A simple curve is not going to intersect each other first of all. So you can cross the things which are intersecting or you have to lift the pencil to make those figures. So number 3 you have to lift your pencil. So that's not a simple curve. Number 4 it's crossing one another. Number 8 you have to lift your pencil. So these are not simple curves, right? They're not simple curves. 1, 2, 5, 6, and 7 are simple closed. Now, are they closed or not? Yes, they are closed also. So they are simple closed curves as well, right? Now, amongst 1, 2, 5, 6, and 7, how many are polygon? Because for a figure to be polygon, it has to be simple closed curve first. So what are simple closed curve? 1, 2, 5, 6, and 7 are simple closed curves. So out of
Yeah.
these only you will have certain polygons. So what was the definition of a polygon? That was forming with line segments.
Line segment.
Not include curvy lines. It has to be straight line segments. So
Yeah.
only 1 and 2 are polygons.
Mm.
Now, from polygon also we can have a definition of convex polygons and concave polygons. So convex was where the, tell me which one will be convex, which will be concave.
Uh, the second one will be a convex,
Yes.
and the
And
first one will be concave.
yes, because in the second one, you will have all internal line segments, and in the first one, you will have all external line segments. So the second one becomes convex, while the first one becomes concave. Right? This much is clear.
Yes.
Okay. Next is, so you can write down the answers. If you do, you have your NCRT. Okay, you don't have NCRT in your school.
No.
Okay. Now, what is a regular polygon? State the name of a regular polygon of 3 sides, 4 sides, 6 sides. Now, what is a regular polygon? I told you the meaning of regular polygon is a polygon having all sides and all angles equal. That's called a
Yeah.
regular polygon. Now, what are examples of a regular polygon of 3 sides?
Equilateral triangle for 3
Yes.
sides.
For 4 sides?
Square for 4 sides.
Yes.
And a hexagon for 6 sides.
Yes, very good. Right. Now, next is sum of the measure of the exterior angles of a polygon. Now, how are we supposed to measure the exterior angle? What happens? Let's suppose this is your polygon. Right. And in this polygon, you have certain exterior angles also. Like this is your exterior angle, this is 90 degree, then this is x, then this is 50, and this is 110. Now you don't know what is the measure of x, and all of them are exterior. So the sum of all exterior angles of a polygon is equal to 360 degrees. Okay. That means when you will add all of these angles, like when you do 90 plus 50 plus 110 plus x, that should give you 360 degrees, right? So you get 90 plus 50 plus 110, you get 250 plus x should give you 360. So x is equals to 360 minus 250. Okay. So x is equals to 110 degree. Understood? So whenever like
Yes.
out of 4 angles, 3 angles will be given to you. So we'll write that not just 3 angles, like you can have 5 angles also, because it's a polygon. A polygon can be of any size. So outer angles, the exterior angles, sum will be 360. Next is you do this example. What does this example say? First of all, you need to learn this formula. The number of sides of a regular polygon is equal to the 360 degree divided by measure of all angles. Now, for example, you have a regular polygon with you, and I'm asking you find the number of sides of that regular polygon. That how many sides does it have? And I say each of its exterior angle measures 60 degree. Okay, each of the exterior angle is 60 degree, and you tell me what is the number of sides of the polygon. So what you will do is you will use this formula. You will say number of sides is equal to 360 degree divided by 60 degree. Okay, so you cancel this, you get 6 sides. So a polygon with 6 sides, a regular polygon with 6 sides has all exterior angle equal to 60 degree. Okay. Now the same
Okay.
question, if they are giving you, find the number of sides of a regular polygon whose each exterior angle has a measure of 45 degree. Now what you will do? Each of the exterior angle is 45 degree. So number of exterior angles is equals to how much? 360 by 45, and number of exterior angle is only the number of sides. So the polygon will have 8 sides.
Yes.
Okay, if you want, you can copy this question. Copy it quickly.
Done, ma'am.
Yeah, done. Okay. Now, similarly, you have this exercise questions with you. Now, what does it say? First is find x in the following. So I told you what is the formula. Sum of all exterior angle is equals to 360 degree. So you add all the exterior angles. So you will do 125 plus 125 plus x should give you 360 degree. So x is equals to 360 minus 2, right?
Ma'am, but it's a triangle, right? So it'll be 180.
No. Exterior angle is still 360 only. I said the
Oh,
sum
okay.
of exterior angle of a polygon is triangle, not a polygon.
Yeah.
Yeah. So for all it will be 360 only. Then for this one also use the same formula. Then you can do question number 1 and question number 2. In question number 2, now you will use the same formula. Number of sides is equals to 360 degree divided by measure of each exterior angle. So here find the measure of each exterior angle. What you will do is you will do 360 divided by 9 you will do, and you will get exterior angle. Right? It goes
Yeah.
either way. If exterior angle is given to you, you can find number of sides. If number of sides is given to you, you can find exterior angle, right? You do question 1 and 2. For 2, you will write the formula also in your answer, right? Do it. Yes, Duhaa completed.
No, mom, not yet.
Okay, just tell me when you've done. Okay, so we'll move to the next one.
Mom, I didn't answer the second one.
You got
Mom, in the second question, it's giving the number of sides, but I don't know how to solve for that.
no problem. Tell me the answers for the first question first. A and B part.
Okay. For the first question, A is 110 degree.
110. You must have done 360 minus 250. So 110.
Yeah.
Okay, next B part.
I got 50 degree for X.
90 plus 60 plus 70 plus X plus 90 should give you 360.
Yeah.
Should give you 360. So X should be equal to 360 minus 210. So, no, it's more than 50 degrees. It's not 50. Oh, no, no, wait. Yeah, it's 50 only. 50 degrees. So 110 degree and 50 degree, right? Now, the second one, it says find the measure of each exterior angle of a regular polygon of 9 sides. So what formula did I teach you? I said number of sides is equals to 360 degree divided by measure of each exterior angle. So now number of sides is 9 is equals to 360 degree divided by measure of exterior angle. Let's call this x. So x is equals to 360 degree by 9, isn't it? So
Yeah.
40. So how many number of, what is the measure of exterior angle? Measure of exterior angle is 40 degree. So each angle is measuring 40 degree. Similarly, you do the second part also 15 sides. So you'll write number of sides is equals to 360 by exterior angle. Exterior angle is x. So x is equals to 360 by 15 degree. Right?
Okay.
Copy
Yeah.
this.
Then, mom.
Okay, now you do for 15. Do the second part. Done, Duha?
And then, mom.
Yeah, what is the
Yes,
answer?
mom.
Okay.
The answer is 24.
24 degrees. Okay, that's correct. Now next is, now come to third and fourth question. Third question reads, how many sides does a regular polygon have if the measure of exterior angle is 24 degrees? Now they're telling you exterior angle is measuring how much? 24 degrees. And now you have to tell me how many sides does it have, right? Similarly, question
Yeah.
4 says, how many sides does a regular polygon have if each of its interior angle is 165 degrees? So 165 degrees is the interior angle. Okay, wait. I'll teach you this. First of all, you should know this formula, that interior angle plus exterior angle is equals to 180 degree, right? Interior angle plus exterior angle is 180 degree. Now, Duhaa, they are giving you the interior angle. How much is the interior angle?
165.
165 degrees. So, if interior is 165 plus exterior angle, now you don't know, that should give you 180 degree. So, exterior angle is how much? 180 minus 165 degree. So, that's 15 degree. So, now your exterior angle is measuring 15 degree, and now you have to find the number of sides. So, this question number 3 involves one more step. The step to first find the exterior angle and then find the number of sides. Why? Because Duhaa, you cannot use the formula for interior angle. The formula is only for exterior angle. Okay.
Yes.
Yeah, please put on your camera. Yeah, please do now question number 3 and question number 4. Quickly do
Mom,
3
can
and
you
4.
show the formula?
Okay. Do question 3 and 4. Yeah, Duhaa, have you completed?
Yes, ma'am.
Okay, so tell me the solutions and please tell me once you've done, okay?
Okay, ma'am. Actually, my mom called me, that's why.
Okay, no problem. Yeah, tell me the third and the fourth one.
Uh, yeah, for the third one, oh wait. Oh, I didn't do that one.
Or did you do the fourth one?
Yeah, I did the fourth one.
Tell me the solution to the fourth one.
I got the answers 24.
24. Yeah, because you will use 360 by 15, right?
Yeah,
And are we getting 24 or not?
yeah.
We're getting 24. 24 sides is the correct answer. Fine for third one also. Now you just look at it and tell me what will be the answer.
Um, each exterior angle. Oh,
Exterior angle is 24 now. You tell me number of sides. See, now this becomes easy. You just now found out
yeah.
that whenever you are dividing 360 by 15, you got 24. So 360 by 24 is 15.
It's yeah,
Yeah, so for the third one, you'll have 15 sides.
yeah.
Now, question number 5 is interesting now. What does it say? Is it possible to have a regular polygon with measure of each exterior angle is 22 degree? Okay, that means they're asking you, can you form a regular polygon if exterior angle is measuring 22 degree? So what you will do is you will find number of sides is equals to 360 divided by 22. Okay, do it and tell me what is the answer that you get for number of sides.
Mom, I got the answer. Mom, I got the answer.
Yeah, Duha, you got the answer?
Yes, mom.
Tell me the answer.
Mom, it's 16.3.
16.3. Yeah. So now tell just Yes, Duhaa. So this is now, you got 16.3, right?
Yes, ma'am.
Okay. So now tell me one thing, that if you're getting 16.3, can 16.3 be the number of sides?
Yes, ma'am.
No, how can decimal? Okay, see, I can have 3 sides, I can have 4 sides, I can have 5 sides. Can I have 3.5 sides of any figure?
No, ma'am.
So then how can 16.3 be the number of sides? It can either be 16
Yeah.
sides or 17 sides. So that means, can 22 be the measure of a be the exterior angle measure? No, it can't be. Why? Because if
No.
22 degrees is the exterior angle measure, then 16.3 sides you get. And 16.3 can't be the number of sides. Right?
Yeah.
Now next is, can it be an interior angle of a regular polygon now? So for interior angle, now what you'll do? What will be the exterior angle, Duhaa, if 22 degrees is the interior is the exterior angle? No, they are telling you, if 22 degrees is the interior angle. So what will be the exterior angle?
So it will be 22 plus x is equal to 180.
Very
And
good. Then
then when
you
we get the
find the
answer of
exterior
that,
angle.
then we divide it from 360.
Yeah, good. So do the B part also.
No, mom, it can't.
Yeah, it can't be. Right? So for both of these, the answer is no. Now what is the question? What is the minimum interior angle possible for a regular polygon? So what they're asking you is, what is the minimum in see, you have, first of all, you need to know what is interior and what is exterior, right? So if this is a triangle, so if I draw like this, so now this angle, and this angle becomes the interior angles, and these angles becomes exterior angle, right? Please make a figure for
Yes.
interior and exterior. Yeah, done.
Yes. Yes.
Now the question was, what is the minimum interior angle that's possible? Now what happens for the minimum interior angle is, you will have the simplest polygon. And what is the simplest polygon? A triangle. And what is a regular polygon for a triangle? 60 degree is the side, because that's equilateral triangle.
Yeah.
So answer is 60 degree. Okay,
Yes, ma'am.
understood? Now copy this one. Copy the question, write interior angle.
Which question, ma'am?
Question number 6A. Copied the A part?
Yes, ma'am.
Okay, now what happens? Now they are asking you what is the maximum exterior angle possible. Now what happens? See, these are related questions. Why? Because tell me one thing. Interior and exterior are related. If interior is more, exterior is less. If interior is less, exterior is more. So if interior angle is minimum, then only the exterior angle is maximum, because interior plus exterior should always form 180 degrees, right?
Yes.
So if one decreases, the another increases, right? So if interior was minimum, that's equal to 60. So 60 plus 120 is equals to 180. That means 120 is maximum exterior angle that's possible. Okay.
Yes.
So copy 6A and B part.